Hello, scholars. Time for our next exciting round of Module 4 notes. Please make sure you have your name and your number up in the top in the corner. And again, go ahead and label as Module 4 notes. Today we're going to start with a Roman numeral 10. Roman numeral 10 because this is Module 4, Lesson 10. 410. Compare and evaluate expressions with parentheses. Let's write that down. Compare. So we're going to talk about how things are the same. Compare and evaluate, which is a vocabulary word I will define for you shortly. Compare and evaluate expressions. Okay. So compare and evaluate expressions, plural. There we go. Zoom in a little bit. All right, let us begin, as I mentioned a moment ago, with some vocabulary. Now, our first vocabulary word is going to be expression. Expression. Okay. Hopefully, this is familiar. It has come up in previous lessons. Expression. An expression is just in math. Anytime you see numbers, symbols, oh, I'm jumping ahead. Numbers, operators, we'll talk about those in a second, those are very important, and or symbols. I was so excited about the symbols, makes me think of algebra. Numbers, operators, and or symbols that are grouped together, and this part's important, grouped together to show a value. And it's going to be a number value, a numerical value. We'll be looking at some of those in just a few minutes. Okay? So an expression, numbers, operators, and or symbols grouped together to show a value. Now, again, there are a few things in here. Numbers, I'm sure you're familiar with. Symbols are symbols, pictures, sometimes letters. The one I want to review is operators. We talk a lot about operations in math. Operators are the specific symbols that show the operation. So, for example, addition, subtraction, you probably know where this is going, multiplication, division. Now, it's a little hard to show the symbols for the next one, but one operation that we need to be aware of for this lesson, you are also going to be working with parentheses. I need to make sure I spell that correctly. Parentheses. That should be an R. There we go. Okay. So, parentheses are considered an operation symbol. It's an operation we have to talk about. We'll get to that in a moment. Add, subtract, multiply, divide. You're familiar with those. Those are the main ones we need to know. And then finally, evaluate. Many of you may know what this means already as well. In math, when we use academic language, the language of the discipline, we say evaluate when really what we mean is solve. But the fancy definition, evaluate means find the number value, there's that word value again, find the number value of an expression. And I'm going to go ahead and write semicolon solve, because evaluate usually means solve. Now, the process varies based on the examples. So for this lesson, I'm going to go ahead and slide this up. We are mostly just going to dive into some examples. We're going to dive into some examples. Okay. You'll be asked to do a few different things. One thing you're going to be asked to do is write an expression that matches a phrase or a sentence that you're given. So for example, if I were to give you the phrase, let's bring up a good one. Here we go. 1/8 the sum of 23 and 17. That is not an expression. That is a few numbers, but mostly words. Okay? This is a statement that we can turn into an expression. 1/8 the sum of 23 and 17. We want to start by looking for any clue words that tell us what operations we're going to be doing. And hopefully you noticed sum is a clue word. Sum is a word that means addition. The sum of. Now I know I jumped right over the fraction. We're going to get back to that. The sum of 23 and 17. The sum of 23 and 17. Now earlier I talked about parentheses as one of our operators. We are going to use that to show that the sum of 23 and 17, this is one value. Now it's not written as one value, it's two numbers being added together, but it has a single value. If you were to evaluate it, you would see that this is 40. Now 1/8 the sum of. This is where things get a little tricky. We've talked about finding 1/8 of something. You can do this two ways. You can take 23 plus 17, this sum, and you can divide it into 8 equal parts. Because remember, fractions are division. 1/8 is this one whole thing, 40, divided by 8. You can write it another way. You can also, let's go ahead and squeeze it in here, or you can write 1/8 times 23 plus 17. This is how you will write it as you get further into algebra in middle school. We're going to mostly focus on this first one for today, but I'll show you just so you have it in the back of your head. We're mostly going to focus on this one. 1/8 the sum of 23 and 17. Well, 23 plus 17, there's our sum, divided by 8. Now, I'm going to kind of scooch over a little bit here, draw one of my little arrows that I love so much. 23 plus 17 divided by 8. Again, we already said 23 plus 17, that sum, and I put it in parentheses to indicate I need to do that first. That sum should be 40. So even though it was two different numbers, they're being added together with a symbol, they have one value, 40. And that is something that I can pretty easily divide by 8. 40 divided by 8 is 5. So, we took this statement, we wrote a matching expression, two technically, but we'll stick with this one for right now. We took the statement, wrote a matching expression, and then evaluated the expression. We solved it to figure out, okay, what's the value of this? Then I divide that by 8, and I get my final value. 1/8 the sum of 23 and 17. This whole thing equals 5. Let's do another one. Let's do another one. Okay. Let's do 15 times, oh boy, 15 times as much as 1/5 of 12. Well, that's interesting. Okay, 15 times as much as 1/5 of 12. Well, we've got some times as much. Times is multiplication. We also have 1/5. 1/5. Normally I don't make the 1 like that, but since we're mixing with words, let's make sure it's really clear. 1/5 of 12. Well, 1/5 of 12, that would be multiplication as well. Anytime we have a fraction of something, 1/5 of something, we're multiplying. 15 times as much as 15 times, we're multiplying, 15 times as much as whatever this is. Okay? And this is really spread out. Let me put parentheses around this part because 1/5 of 12. The way this is put together tells me this is one value I'm going to be dealing with. I want to find 15 times whatever 1/5 of 12 equals. 15 times 1/5 of 12. Now, evaluating this one is a little more interesting. 1/5 times 12. Well, think about it. If I have 12 little fifths, 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, blah, 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 blah. I have 12 fifths. That is the value of what's in the parentheses. 1/5 times 12 would be 12 fifths. Now, don't worry about trying to make it into a mixed number. We're not going to do that yet. We're still working, so we don't have to bother with that. Only at the end. 15 times 12 fifths. Whew. Okay? Again, there are a few ways to do this. We've kind of talked about how if you have 15, here's our whole number. We're multiplying times a fraction. You just take this whole number and divide it by the denominator. So 15 divided by 5 becomes 3. The 15 and the 5 just kind of cancel each other out. The 15 becomes a 3. The 5 disappears. Now we've just got 3, right? 15 divided by 5 is 3 times 12. And that should get us a final value of 36. We're going to do a lot more practice in class going through looking at these kinds of statements and then changing them into expressions. It takes practice to read them carefully and know what goes where the parentheses go. Usually you're going to see a couple numbers that seem like they should stick together first. Okay. We're not finding 15 times as much as 1/5. Well, I guess we kind of are. Anyway, these two go together. That's why the parentheses are there. Now, let's do one more example. It's going to look a little bit different, but then we'll wrap up for tonight. What we're going to do is we're going to take a look at two expressions, and we're going to try to compare them. We're going to try to turn this into a greater than, less than, or equal to statement. Let me show you. So, for this first one, I'm going to go down a little bit. Let's say we have 4 times 2 plus 4 times 2/3. That's a lot. There's a lot going on there. Okay. We're going to compare that, greater than, less than, equal to. We're going to compare that to 3 times 2/3. Now, the key here is to not actually go through and calculate. I can use math. I can use the order of operations, which we've talked about in a previous lesson. I can find out the exact value on both sides. I don't want to do that. I don't want to do that. So I'm going to look at both sides to start with, and I'm going to look and see if I see anything that looks the same. Okay? I got 4 times 2 plus 4. I don't have any 4s or 2s. Well, I have 2/3, and I have 2/3 over here, and I'm multiplying both of them. Hold on a second. So for a moment, I'm going to go ahead and say, all right, times 2/3, times 2/3. That's happening on both sides. So I'm going to use parentheses to isolate, to section off everything else. I have blah, blah, blah times 2/3, and I have blah times 2/3. Okay. I can kind of ignore the 2/3 for a minute. They're the same. And just look at this and say, okay, 4 times 2 plus 4, 3. Which of these do you think is going to be bigger? Do you think they're going to be exactly the same if I worked this out? 4 times 2 plus 4. I've got 4s, which are bigger numbers. I'm multiplying, which makes things bigger anyway. This is going to be a lot bigger than 3. So without calculating the final answer, I can just write 4 times 2 plus 4 times 2/3 is greater than 3 times 2/3. It's about looking for patterns, looking for what repeats, putting everything else off to the side, and just comparing those pieces. Now, sometimes it's not quite that simple. I'm going to do one more. Just one more. I know this video is getting a little long. Let's do one more. We have 5 times 3/4, 5 times 3/4 times 2/5, compared to, that's a weird looking circle, 5 times 3/4 times 2/7. Now again, we want to look. What do we see that is the same? We've got 5 times 3/4 times 2/5. We have 5 times 3/4. Okay. Well, 5 times 3/4 and 5 times 3/4, those are exactly the same. So I'm going to focus on times 2/5 times 2/7. And actually, shame on me. Should put the parenthesis inside like that. Sorry, folks. I think that's the second time I've done that to you on this lesson. All right. Now that we have the stuff that's the same kind of separated, we have the things that are different, 2/5 versus 2/7, we can compare and try to determine which side would be greater, what would be smaller, or are they the same? Well, we know they're not the same. 2/5 and 2/7 are not equivalent. They're not the same. Normally, I would not be able to compare two fractions that have the same or have different denominators. Can't compare fractions when they have different denominators, but they have the same numerator. So in this case, I can. 2/5. If I break something into fifths, those pieces are going to be bigger than if I break it into sevenths. If I have a candy bar and break it into 5 chunks, each of those chunks will be bigger than if I had the same candy bar and broke it into 7 chunks. So fifths are bigger pieces than sevenths. I would rather have 2 big pieces than 2 little pieces, so this one is greater than. Again, could I go through and mathematically calculate the exact value? Yes. Would that take a while? Probably. As mentioned previously, you're going to do more of this in class. If you have additional questions, please write them on a sticky note, something like that, so that we can discuss. We just want to get used to how we read expressions, how we translate them in numbers, and then look at how we can kind of play with groupings a little bit. All right, that's going to be it for this time. Thank you, folks, for following along. I'll see you in class.